whether they believe in what we used to call the blob method or the sort of delicate tracing method, right? And so, you know, at the beginning we had these big discussions about whether you're better off just, you know, drawing a big circle around what looked like damaged area without trying to trace the edges. And that was Branch's initial point of view, and a lot of people believe that. Anjan, I think, still holds to that view. And I think over the years we've sort of come more to something of a refined tracing the edges view, or something in the middle of that. So
yeah,
there's no right answer here, so you should know that.
And it's changed with the warping thing.
Yeah, I mean, presumably there's a right answer, although I don't know if we
it's a lot harder.
It's also noted that sort of the blobby method, I mean, different neurologists use different templates. So there's certainly, this is using the CH2 template. The other is the DiMaggio template, which is...
It's a lot fewer slices.
A lot fewer slices. It's a lot harder to judge how this one-to-one sort of mapping is taking place. And so, therefore, they tend to use a lot more of a blobby method in terms of, well, I have only 9 slices, but my clinical scan that I'm tracing from has something like 27, right? So you really have to know your neuroanatomy to make the judgments on how you're going to transfer, something that's 27 onto 9 plates. Right?
And my understanding is that in the DiMaggio lab, Hannah DiMaggio does everything.
She does everything.
Tracing,
yeah.
And she's a neuroanatomist, long, tremendous experience.
One more quick question about the blob versus delicate method. What implications do you either have for the warping that you'll do next? Because you might imagine that if you do it incredibly delicately and then warp it, you'll get all these delicate things that are in the completely wrong place. That might be an argument for a blobbier method. I don't know.
Well, we have a hypothesis that it may not actually make a big difference between blobby and sort of more artistic, because there's some smoothing that goes on, and there's some the warp itself makes it more blobby, if that makes sense. So so in that sense, whether you get the actual voxels, it probably doesn't make a huge difference, is our guess, but we've never actually tested that.
The thing to keep in mind about boundaries is that each boundary is a sort of distinction you're making between two regions. And when you draw one subject's boundary in a particular location, what you're saying is you're making a distinction in that subject between voxels on one side and voxels on the other side. So one subject going from group to group is unlikely to make a huge difference in a piece. It could, but it's unlikely. In order to be invested in the idea that being incredibly detailed is going to be worthwhile, you have to believe that a few subjects, more than 1 or 2 or 3 probably, or in particular consequential subjects, are going to have their boundaries in the same place. So I guess I call the body.
Yeah, sorry.
And also, as just a practical matter, I know this has been discussed before. So obviously, Grant showing us how to do this is very nice, but ultimately, to do this, you need to sit down with the scans and do the drawings. And I know we had planned at some time to have a sort of a set of, here are the, here's what we think for this person is where their lesions are, that we can then, as people are training.
Exactly. So that is
that's number 4. Practice, practice, practice.
And you have identified.
Sure. Yeah. I got a set of easy ones and hard ones. So.
And we also put aside some of ours that you won't be practicing on for those of you who want to actually test reliability. So we'll have that available.
I was just going to ask, on average, how many slices do you draw?
I don't know about an average. It's hard. It's really hard. They really can be. So it's the superior inferior dimension that is gonna matter, right?
It depends on the protocol. So the typical protocol that we have used, we have 160 slices. We downsample it to 8.
Nobody has slices. Nobody has lesion. That's the whole space.
No, that's the whole space. So depending on how big their lesion is, right?
And this is a pretty big lesion.
Oh, this is a real, because this one extends pretty much all the way to the top, pretty close to the bottom. So this is a big lesion.
Are you going to talk about the down sampling next time? Is that part of anybody's lecture? Just to talk about how.
Yeah, that should be next week.
Just to mention how that when and how that is done.
So you down.
But again, it really depends on how extensive sort of the spidering Grant was talking about in that lesion. If there's a lot of that, then it could take you a day and a half to really.
And that's straight work. You will go insane if you sit there for 12 hours straight looking at these things. Is that voxel damage? Is that voxel damage? Because you have to do that around the edges of these. So it gets tedious. So, you want to have an iPod or something to, or like have other work that you can, take a break and do something else. You'll go blind. I clearly need a stronger prescription after.
About the down sampling, so do you do that before or after you draw?
Before, so that there's less slices to draw.
Okay, that's what I thought.
One of the ways when you're clinically looking at an MRI and you're trying to bring out lesions is to adjust the brightness and contrast.
Mm-hmm.
So do you ever play around with those settings?
I don't. I just kind of take whatever I'm given. So no, you could do that. I don't know that it's actually gonna help you much, right? Because you may extend 1 or 2 voxels because something looks a little shadier at a certain contrast. I just kind of go with whatever I'm given and just leave it at that.
For these MRIs, we don't tend to do that, but it should be noted for the CT.
Oh yeah.
It's critical that you adjust.
Pretty good stuff in MRIs too. There are times when you'll have some abnormal tissue that is not in a good range for your contrast setting. It's not the middle of the lesion, but it's helpful.
Can you adjust it here?
No, this isn't adjusted.
Interact with the kind of monitor you're using and the lighting conditions in the room.
So adjusting meaning like you display some intensity distribution and then kind of adjust so that the range impacts too much of it, something like that.
Yeah, Grant, do you want to just show?
Yeah, so I'm just trying to remember. Let's see. What do you like? Click and drag or something? Or?
The number, yeah, you can do like right click and drag.
Is that what it is? All right. So you can like right click and select an area that you want to make more or less contrasted. That's to restore it. So I personally don't find it very helpful. So once you have gone through and drawn all your slices in the axial, you'll be like, yeah, I'm done. But you're not. You got to go back and you got to check it in the coronal view. And you'll see that actually this one, see that strip on the outside there? Does anybody remember what that is? Yeah, you got it. So you don't want that to be lesioned. And what you'll find is that sometimes it's hard to tell when you're drawing in the axial how far you've gone, but you can see in the coronal it's a lot easier. And so what you'll do is, again, slice by slice, you're going to go and you're going to erase the dura. You're going to do that again, so on and so forth. Making sure, and if you go too far up, then you got to fill it in a bit more. So you want to make sure you're staying inside the dura on the medial side of the brain, and you also want to make sure you're not going into the ventricle here, because that's just fluid. There's no processing going on there. So you kind of go through and make sure you're within your boundaries, and then you're like, yay, I'm done, but you're not. You have to go back again to the axial and check that all of these little things so you can see I kind of deleted 2 things here. Well, that really should be this whole thing here. So sometimes the changes that you make in the coronal will look weird in the axial. So you kind of got to flip back and forth to make sure that so then once you've done all the 2 checks, then I would say send it to Branch to have him check it. So all that seems pretty straightforward. Just highlight the stuff that's damaged and leave the stuff that's not damaged. There are a number of things that will show up that look like stroke, but aren't.
Grant, do you want to show also the saving?
Right, sorry. That's absolutely so. Thank you. Draw. This is in your draw. Save VOI. The VOI is volume of interest. So that's what these things are. And you just, put in your name or whatever you want to call it, and click save wherever you want to save it. And
there's no auto saving, right?
Correct. So if you close out, it'll say, oh, do you want to save? You say no.
You want to keep saving? Is that what you mean?
Yeah, right. Yeah, that's right. That's a very good point. Yeah, I save. That's a very good point. I save probably every 2 or 3 slices that I draw. Thank you, Steve. That's a good point. So, things that could pop up that look like stroke but aren't. Sulci. Sulci, your brain has all those lumps on it. Those lumps are called gyri, mountains. The valleys are called sulci. They're just sort of spaces where your brain kind of curves inward. It's filled with fluid, and on a horizontal cut through one of those, it just looks like an open bit of fluid. So one sulci in particular, it's actually the Sylvian Fissure, can be problematic. And actually, I'm actually going to show you this on the template. So these things are normal, axial. Okay, so you see all these parts that sort of duck in here, right? And then you have something like this over here, right? You're like, well, that's weird. It's kind of in the middle of the brain. It's kind of surrounded by tissue, but it's a big hole. What's that about? Well, it's a normal sulcus. It's just a horizontal cut through it. And so one of the ways you can tell a sulcus from a lesion is that there's gray matter around it. You see these ribbons of gray matter. So that's a big clue that it's a sulcus. Sometimes it's hard to tell whether that gray matter is lesion or not. So it's not a surefire thing, but it can help. So this is the Sylvian Fissure, this thing that's jutting in here. And this is particularly for aphasia. It separates frontal from the temporal, and the insula are sort of tucked in there. And that's where we see a lot of aphasic symptoms if you have damage there, particularly on the left. Now, when you have damage, sometimes this will sort of open up and look a lot bigger than it is. Sylvian Fissure, here we go. So the question, you can see this person has a lesion, here-ish. But you can see on the side here, this is Sylvian Fissure. This is normal. It's got this ribbon of gray matter around it, and it's normal. It's jutting in. And here, it's jutting in. And then on this side, there's gray matter. But here, this is what you should be looking for, these cuts. It looks like it's just cut out, or scooped out with a spoon, right? So that edge is clearly lesion. So now the question is, does this lesion go all the way out to here, right? Or does it kind of go to here and leave the Sylvian Fissure? One way to tell is to look, when you put your crosshairs here. So this is kind of the area that's in dispute. And then look at it in the other views. And you can see that actually, this is more or less a normal sulcus. Well, normal, it's atrophied, but this isn't. You see this, there's gray matter that sort of loops around here, and you can kind of scroll through a little bit, and you can see that there's this gray matter. It's a big sulcus. It's certainly bigger than you see over here on the other side, but that's just atrophy. So actually, the way we would draw this, well, I'll show you.